Hello, and welcome to the APAC Hybrid Cloud Kopi Hour. We are back from a small break where we've been away for a little while since February, but we're back with a live broadcast coming to you from Sydney with the usual cast of characters. I'm August Simonelli. I'm a technical marketing manager here at Red Hat. And as a reminder, this is the Kopi Hour, not the coffee hour or anything like that. That's a traditional beverage found in Southeast Asia and Singapore. Now look at this. I have actually here a Kopi cup. It's not actual Kopi in the cup, but it's an actual traditional Kopi cup from Singapore. I'm very proud of that, and I've been prepping my Nescafe in there. Now, of course, that's not why we're here. You're not here to watch me drink coffee, as fun as that may be, but we have our usual co-host. We have Dev Shanbag. Dev, why don't you introduce yourself?
Hi everyone, I'm Dev Shambhag and let me toast my virtual coffee with you all.
There we are.
Been with Red Hat for around 7 years, worked with the services team here in Melbourne, Australia, and glad to be part of this CopiR project with August and really excited to hear and listen from our presenters, Bryon and Ben.
That's right. And that's a wonderful introduction to our presenters. Let me first kick off by introducing Bryon. Bryon is an associate principal solution architect here at Red Hat. Go ahead and introduce yourself, Bryon.
Oh, hi. So Bryon Baker. As August said, I'm an associate principal architect in Melbourne, Australia. I specialise in the financial services sector and helping Red Hat and our customers in that vertical be successful with Red Hat's technology. Over 30 years, I guess, in IT across a bunch of sectors, commercial, public sector and financial services. Really happy to be here today and share what we're doing with cloud application modernization and cloud migration.
Excellent. And joining Bryon is Ben Farr. Ben is also an associate principal solution architect, I think also based in Melbourne. But yeah, why don't you go ahead and say hi?
Hi there. So I'm been with Red Hat for about 8 years, but I sort of come from 25 years of application and development and architecture experience. I've recently sort of got a job, so I'm now sort of looking at telco accounts in Australia and New Zealand. But before, I've sort of covered a fair range of industries, and I've got interest in that modernisation, event-driven architecture, and the open hybrid cloud.
Yes, excellent. Yes. Yeah, I've been working with Bryon and Ben and of course Dev for quite some time. So it's really exciting to have them on today and to get into this kind of provocative topic, the next evolution of cloud migration. So I love the title. We worked hard on making it, hopefully you're all sitting out there going, oh, what's happening there? But what we wanted to lead in with a bit is that what is cloud migration? Where are we going with that? And I was reading a stat, I think it was from the Voice of the Enterprise survey, saying that 70% of organizations are now multi-cloud and hybrid cloud. So before we dive in, I want to level set a little bit about how we got there and what these things are. So multi-cloud is using two cloud providers, and then hybrid cloud is mixing and matching those cloud providers, is mixing on-premises, is mixing bare metal physical. I'm on track with that, right? Is there any more nuance to that, or is it that straightforward?
Well, I think it's a little bit more nuanced than that. So I mean, hybrid cloud, multi-cloud, you've got the stretching, your existing on-premises infrastructure out to the public cloud, or it can, because there's a bit of, people use the words differently, right? Multi-cloud I tend to use about where if I've got multiple public clouds that I'm using and I'm deploying across there, and hybrid tends to include that plus going from on-premises to the public cloud. Absolutely. So that's probably the way I'd finesse the words that are in there.
Right. So you used I think an important word that I wanted to kind of go into. You said stretching, and I'm not talking about this morning's exercise, which, is always good, but how did we actually start to migrate? And I know at Red Hat, we're all about cloud migration. And in the past, we actually were about virtualization migration. I know Dev and I used to meet up. We would be in like a telco data center. I remember visiting these data centers, and the telco folks would say, you see that $1 million piece of equipment, it's like 35 years old. You'll never replace it. And I was like, well, we're going to make a VM out of it. And we're going to put it on OpenStack. You remember that, Dev?
Yeah, it's been a while. I mean, that's how I see things happening. Initially, we went from physical to virtual. There was a point where everyone was looking at private clouds, and that's when you and I kind of started working together. And recently, I read a stat where in 2022, the number of cores that OpenStack was servicing came to 22 million cores. So that's been quite a journey. And with that, it has evolved as well. These days we're looking more towards microservices and going towards event-driven architecture. I don't really want to go in that direction. I want to listen from Bryon and Ben, but it's been a while.
Yeah. That's right. And so there's been a process here, right? We were going to OpenStack, we were putting it onto VMs. OpenShift comes along, containers come along, and we're looking at new tools to get away from virtualization and into containers. Upstream tooling is Conveyor. We have productized versions of that. So we're getting into more of a discussion around rehosting, replatforming, refactoring, those types of things. So, Conveyor can move VMs into OpenShift Vert, or move your Kubernetes infrastructure from one to another, and that kind of thing. So now we're actually starting to move. We're getting into a movement type of thing, and we're evolving in cloud evolution to a different thing. We're not just building a VM, which was super exciting when I was a sysadmin, but we're actually moving left to right. It's a bit of an imperative approach, right? We're doing this, we're doing that, we're doing this, and moving those pieces across. So then I think that evolves, and this is where we want to get to, into things like Submariner. And I don't know if you guys have more to say on Submariner, but this is a tool that allows you to do cross-cluster network communication. It's CNI for OpenShift. And actually, we don't now necessarily need to move workloads, but we're starting to look at ways to connect workloads. Am I on track with that?
Yeah, I think you're close. I mean, the end goal, right, of tools like Submariner is to interconnect my workloads and be able to deploy and have multiple placement choices for my workloads across multiple clusters. That's ultimately the problem it's solving, right? And the way it's doing that is it's joining your Kubernetes clusters at the hip and setting up a VPN between two clusters there. So, and then because as you know, Kubernetes uses a service level of abstraction for communication between the pods. So it uses services. So you end up with a special service namespace, service address that is multi-cluster that uses Submariner as the backbone there. So that's the problem it's trying to solve for sure.
Right. So this is cool, right? So we're tracking the evolution. And it all kind of gets wrapped up in this famous thing. And I'm going to look at my notes, but it's rehosting, replatforming, repurchasing, refactoring, retire, and retain, right? These 6 strategies for migrating applications to the cloud that AWS set up. And this is kind of well known, and we've kind of moved along. And I got to this point, and I was looking at Submariner, and I thought, so this is cool, right? So we've arrived. Cloud migration does these things. We can stretch some clusters. We can move some workloads. We can do a lot of things. But that then kind of says we need to start asking some more serious questions about where we're going here. And that's where we're trying to get to today on the show. And it comes up that I'm curious, right? Is there a next evolution? Is this really the next evolution? What do you mean by that, Bryon? Like we look at this title, but what do we mean? Hybrid cloud solves this, right? So doesn't that solve the problem?
Yeah, so I'm being a little bit cute when I say the word next evolution, right? But what you end up with, irrespective of whether you're trying to use some kind of mesh or some kind of VPN technology to interconnect Kubernetes clusters, or whether or not they're just globally load balanced, doesn't really matter. By having a Kubernetes platform that is in the public cloud, on premises, in 2 different public clouds or whatever, that kind of gives you a landing space. And Red Hat's open hybrid cloud, right? Which is the whole idea of the open hybrid cloud is to put OpenShift everywhere. And so what's the benefit of that is it's the same Kubernetes flavor everywhere, which means that from the application team's perspective and from the SRE, site reliability engineers who have to support these things, it's consistent everywhere, which means that they can land the same thing everywhere with no code changes, right? But that's a very structural solution. right? So what we need to, what it doesn't give us is a way to execute, right? So this, and kind of rewinding back a little bit, it's also about the cloud migration programs where I'm starting with an application running on a virtual machine, and I break up that monolith and I go and put it on the cloud. And that piece of work, right, requires usually a whole teams to down tools from developing any business features, right, and then focus that re-engineering effort on getting the application cloud ready. And I guess this is where the next evolution comes in, because, you know, while we may have these consistent Kubernetes platforms everywhere, right, that's a very structural solution. It gives me a constant landing strip to go everywhere, but it doesn't give me a way to execute. And these big migration programs tend to stall, right? I've seen this on every single customer that I've worked with, and in my previous life before I joined Red Hat 4.5 years ago, is that these big re-engineering activities, right, really they come at the expense of delivering business features, because the 100% of the workforce is getting everything ready, right? So the next evolution in my wording there, the idea is, how can I, instead of use a cloud migration program, how can I do more out of, get my stuff migrated to cloud out of BAU, business as usual, or project investment, right? And that's the idea. And this is where I see the pendulum shifting a little bit, where we can start to actually not have to do massive migration programs and do more. Think about the cloud migration as a multi-year part of the application lifecycle. And how can I get that application out to the cloud through project funding or business as usual effort?
Right. So you're telling me that I can be doing my usual day-to-day work and suddenly I'm in the cloud. I mean, it's part of the actual process, so that, okay. And then you use that other word. I always hear this, the monolith thing, right? That we're going to strangle the monolith. We got to break up the monolith. But how do you know when that should be broken up? Like, how do you break it up?
That's a good question, August. You know, why do we want to break it up in the first place? You know, some of the goals might be simplification. Some of the goals may be it's sort of just too complex. My engineers can't really, you know, have a fast rate of change around it. Maybe there's, you know, less testing. Maybe there's lots of manual testing when you're sort of deploying that monolith. So breaking it up brings in a lot of value just beyond the normal ability to maybe scale up sort of certain aspects of it, or simplify it, and really sort of it's about bringing more speed into the business ultimately.
That's cool. Nice. Cool. All right. Well, so okay, so we know where we are now. We've moved along. We've got this process. How does Red Hat do it now? I mean, can you show us more? I mean, what there's demos, I know. So what else can we talk about? What can we get into? Let's see it.
Sure. Well, so what we're going to do is I'll start with a little bit of slideware just to kind of introduce where we're going to go with this. But essentially, the story that we're going to show you today is we're going to start with the Java monolith, and then Ben's going to show you how to break that up, and the tooling that we can use, that we've got available, and the upstream tooling that's available to help you support in that. And then I'm going to show you how you can start to move the parts around, right, without the application being aware, because, you know, traditionally you can't move anything unless you're using DNS to resolve its location. And I'm going to show you how you can do that without the need for DNS and without any application code changes, and how Ben is going to play the role of the developer. And then I'm going to take that on, and I'm going to take the role of the integrator, and then show you how we can move that all around using a really exciting open source project that is just about to go GA with Red Hat, and will be announced at Summit. Cool. But you're getting a little bit of a sneak preview today, because this is a pre-announcement.
That's the way we do. All right, shall I bring those slides in? We'll go ahead and get into it, eh?
Yeah, sure thing. All right. Okay. So, you know, as August said, right, whether you're doing any flavor of the 6 R's, when you're replatforming, rehosting, or refactoring, right, you're always going to be moving something around, right? And I've talked about, you know, Red Hat's open hybrid cloud, and how it kind of creates this constant landing strip, this same thing to land everywhere, right? And the benefit that brings in is, you know, if you've got a federated Kubernetes approach to cloud migration, you'll start with your application and then, you'll refactor, or maybe you're building something net new. And maybe you want to then take that out to EKS or GKE or AKS. And so, that's a replatform activity, right? And, as part of that, when you're ultimately going to hopefully decommission that monolith there, that the replatform there are differences. You've got to integrate that application into the service management fabric, the security fabric. The CI/CD pipelines are going to be subtly different. The way your SRE team are going to support that in the heat of the moment at 2 o'clock in the morning when something goes wrong is going to be different depending on where it lands. Now, the hybrid cloud approach, the open hybrid cloud that Red Hat promotes, is about having a constant fabric, an OpenShift fabric everywhere, right? And it's about, as you're building net new or refactoring, you want to take that out to the cloud. It's not a replatform. It's a redeploy activity. You're turning a replatform conversation into a placement conversation, right? Because you've decoupled the application, the platform, from the SRE team. It's that same experience, so that they're maintaining this application there. And that's fundamentally how it all works, right? But as I said, that open hybrid cloud doesn't answer two very, very important questions. And one is, if I have a traditional application, how do I strangle that in the most efficient way possible, right? Or if I have something running on one cluster and I want to move it over to some other flavor of Kubernetes, another cluster, how can I move them in the most efficient way possible, right? So, these dynamic questions, as opposed to this structural solution that Kubernetes everywhere provides, right? And that's where, really, really excited to actually be introducing a new product that we've got, Red Hat Service Interconnect, which is powered by an open upstream project called Skupper. And it really deals with the fact, it's a little bit of a Swiss Army knife, but in the context of this discussion today, it really deals with the question about, when I'm moving parts around the place, how can I do this in the most efficient way possible, right? And so then it adds this other dimension, this third leg to the how do I get to cloud pillar, if you like. And it's this next generation cloud integration. It shifts networking left and makes application component placement choices an application team consideration. And what's cool about it is, as I can place my application components anywhere, is it kind of rides on top of all of your endorsed network security and security flows and can't subvert any of that, right? So it's automatically endorsed from a network and security perspective. And when you're doing that, you're doing it without any application changes required. And you're going to see that in the demonstration very shortly that we're going to run you through. So which means that I can start to unpick tightly coupled systems and start to place these bits that I want. And I can federate my application architectures across clouds. I can implement a multi-cloud strategy as well. And I can do that without needing platform teams. It's application teams. So the skill set becomes a lot lower as well.
Right. And so when you're saying shift left, you're actually saying take these constructs, these network constructs, these things that when I was a sysadmin, it was like the network team did that, and put them into the code, put them into the developer space, but keep controls over them so that we can still not go nuts and have exposures and stuff like that. That's what you're talking about.
Yeah, I'm basically saying that when I shift it left, it becomes a developer or an application team discussion and conversation, right? I mean, obviously you can't change the laws of physics, and network latency is going to always have to, part of good systems engineering design principles have to be applied. But where I place the components, right, is an application team discussion here, and it doesn't require a platform team or to be part of that conversation at all. In this, so long as I've got network connectivity between two places, right, I can place these things wherever I want them to be.
Very cool. All right. Yeah. Thank you.
So, just quickly before we start running over into the demonstration here, right? So, the idea is we can now federate our system architectures and the data access everywhere we want. I can deal with the data gravity challenge. I can deal with my data's going to be here, and I can start to move the components around over anywhere I want on, whether that's on a brownfield, a traditional system, like a virtual machine, or whether it's on a Kubernetes ecosystem, it doesn't really matter. And we're moving away from these coarse-grained networking solutions that are always DNS-centric, right, to creating this link fabric right, that uses service names to be able to resolve the location of where anything is, which is building on how Kubernetes works, right? And it does this using an overlay network that I'll get to at the minute. So it's all running on top of layer 7 to be able to do that as well. So, now I can pivot to this locationless architecture, as I said, where I can move the parts around, and I've got the what we're calling the Skupper, or the service interconnect routers that are everywhere, that create a multi-path network between these routers that will let any endpoint be able to get to any other endpoint, and with a guaranteed delivery as over a mesh network that's there. So I can now interconnect, any Kubernetes flavor, virtual machines. I could have a connected edge with Internet of Things, or maybe even some kind of field programmable gate array as a hardware system, whatever that may be, right? And I can start to move these parts anywhere I like around there, and it's an application team choice.
Right, and this is, I can see on here, I can see Hyper-V, VMware. So what you just said, we're not worrying about, it's not only for specific types of systems, it's a networking piece.
Exactly. It's working at the application layer, but we can actually integrate everything, heterogeneous platforms, no matter what they may be. It's not tied to any OpenShift, or it can work with EKS, AKS, RHEL, CentOS, any flavor of Debian, you name it, right? And we can integrate our applications across there. So as we're breaking these things up, modernizing them, we can move these parts around, and the application is unaware.
And it's great because it's real world, right? I mean, this is what our customers have. This is how our stuff runs. You have multiple pieces. Excellent.
Yep, you're going to see that, and very shortly we're going to demonstrate that exact thing. So I'll give you a little bit of an example, and let me just turn on my little laser pointer here so I can kind of direct where your eyes are looking. But so over here we've got we've got a New York site, and over here we've got LA, and we've got an accounting system running over in LA, and this accounting application needs a payment service, right? Now, normally in a Kubernetes world, we would just use the service name and be able to resolve that, right? But the trouble is the payment service lives over in LA, right? And so what we do is by deploying service interconnect here, and we put a router at each of the sites, right? We actually publish the payment service to the mesh network, and then it'll appear over here as a local proxy. So the accounting app thinks it's talking locally to a payment service, but what actually happened is that payment service lives over in New York, right? So now, and then maybe even that accounting service started over in New York, but we just moved it to LA later, right? And then we can actually take everything it depends on with it, right? And so then we've got this network here, which is running with an MTLS connection between them. So you could even do this over the public internet. So the accounting service can now get to the payment service, and it has no idea that it's not talking, that it's talking to a remote service. Another example is where we can actually take in this case here, we've got a database, right, that's running, say, on VMware. And then we can use what we're calling a service interconnect gateway, right? And we can then publish that database as a local service on Kubernetes. So when that accounting application wants to talk to that database, it's actually going to talk via a local service name. Now, this service interconnect mesh network is going to pick that up, and it's going to then effectively deliver that request over to the TCP database on the other side. What I could also do is flip this around, right? And that is, I could put the database on Kubernetes in my application on VMware, say, and I can publish something that would normally need TCP to get to on Kubernetes, right? And make that available to an application that's not on Kubernetes. Now, what's interesting is the normal way you do that is you have to open up node ports, right? Which is, it's problematic in Kubernetes. But with this, we don't need node ports, right? Because the application thinks it's talking to something that's local, and you're going to see this in a minute.
Right. So Skupper is just handling that. It's like flinging it back over. It's saying, "Trust me, I'm here," and then we trust our data to go across and it to manage
everything thinks it's talking local host, and that's going to be really important. Ben's going to talk through this as he breaks up the monolith, right? As you break up those components are used to talking as though they're all local to each other, right? And this is what's happening is this, the service interconnect is letting everything think it's talking locally, right? Even though it's not, right? And that's kind of key to the whole thing, right? And it also, the way it does this is when you set up the routers between them, you set up, and what it creates is an MTLS connection between them, right? So it's a zero trust network, right, between them. So that's there. And what's also interesting about it is that it's multi-path, right? In this case here, I've got 3 routers with each router connected to the other 2, which means that if the connection between Frankfurt, Germany, and Geneva was down, then if the site over here in Geneva still needs to get to Frankfurt, it will actually go via Zurich to get over here. So it's a multi-path mesh network that also gets created there. So not only is it zero trust, but it's also got smart routing.
Right, so you're getting resiliency out of this as well.
Absolutely. Now, how's it all doing this? Right, well, if you think about Kubernetes really is all things talk about layer 7, unless you're using a metal Ingress controller or a metal router on Kubernetes, then everything's talking layer 7. But what's interesting is we've got layer 3 or TCP or layer 7 connectivity being delivered by Service Interconnect, right? And what it does is it's an overlay network, right? So it's using this slide's not quite right, because it should actually be, it's using layer 3 connectivity, and layer 7 is what's happening here. But the idea is I can now have HTTP, REST, or gRPC service-to-service communication, or I can have TCP right in there, and it's all being transported over layer 7. So it's using your normal Kubernetes egress, right? No special load balance ingress controllers required for this to work. So now that we've got, what is Service Interconnect, right? We can now start to say, well, if I've got this thing which has a locationless application, we can now start to answer these questions about how can I strangle that monolith in the most efficient way possible? Or how can I move workloads from cluster A to cluster B in the most efficient way possible? And let me run you through an animated example before I then hand over to Ben for the demonstration. Okay, so say over here, we're starting with our traditional application, right? And, what we would do is we would deploy a gateway locally and a router out to cluster 1. In fact, this, by the way, is going to be the demonstration almost that you're going to see, right? And now I can start to hollow out that traditional application and move some of its components over to Kubernetes cluster 1. Doesn't have to be OpenShift, right? And what happens is service A, if it needs to talk to something that's still in the old monolith or even the database, it's going to just talk locally, and then the router is going to intercept that and deliver it over here. Or if service A needs to talk to service B, or maybe something in the traditional app wants to call what has been refactored into service A, well, it's going to hit the gateway and it's going to effectively be serviced out on the cluster 1. Now, say I want to take that out to the public cloud, right? Well, I've already done my refactoring and part of it's running on Kubernetes. Well, now I can just complete that, move that network, stretch that out to cluster 2, which is in the cloud down here, right? And then I can actually move service A and service B out there perhaps. And then that leaves a proxy sitting over here on cluster 1 that service C will still think it's talking locally, but service A will be able to then effectively be resolved via the network, and then service A needs to talk to the database. It'll come all the way over here, right? Or if the traditional application wants to talk to service A, it'll hit the gateway and be delivered over here. So it means I can actually start to move these parts out and around, but no application code changes is being done when you do this, right? I can make the Service Interconnect network is handling all of that. Right. And so, this is really interesting. If you're an OpenShift customer, as you're moving off OpenShift 3 to OpenShift 4, I can start to rehost my applications over there. Or I could use this to progressively migrate out to cloud, right? And I can do this with no application changes. I could start to think about how I fund my migration programs different and remove the need for dedicated migration funding, right? And then end up with smaller units of migration cost, which therefore increases less cost and less risk, right, in there. So, so with that, I think, I'll hand over to Ben, right, who's going to actually start the whole journey of how to refactor that monolith. So, August, you can.
I can.
Sharing my screen
and we got a funny comment in the chat, right, from Dwayne here, where he's talking about breaking up the monolith, critical job skill. I think that's an interesting point, right? It affects the way we do business, right? Understanding how to work in this new way.
Yep, absolutely. And Ben's going to actually show you that right now, right, and lead you through some of the tooling to help you do that. Right?
All right, Ben, over to you.
Absolutely, and I totally agree with that comment. It does take a lot of expertise in terms of sort of even sort of grasping, you know, what the monolith does, and you know, in order to how to break it up.
This is abstract art.
Yes, it is. I found this diagram and I thought of a monolith when I saw it, but you know, when I always remember a comment, you know, early on in my career, it's, you know, it's really not the number of applications or components that, you know, make things complex, but it's the amount of dependencies in between them that really sort of make things complex. And, you know, in my previous life, I've broken up a few monoliths myself, and I could usually give a pretty good estimate of how long it would take to migrate an application to a new version, break it up, and, you know, easily scale this for multiple apps. But when you come across sort of monoliths with deep roots such as this one in this diagram, you know, the effort starts to climb very quickly. And I'll give you an example. You know, I was tasked with sort of a monolith, effectively a monolith, but it was sort of in 100 integration bundles, but there were 400 links in between them. So that's an average of, you know, 4 dependencies of each module, and they were all tied to each other like a sort of bowl of spaghetti. So you lifted one up, and, you know, all these bits of spaghetti came with it, and you can't, it's very difficult to break. So, you know, how do you even start to pick it apart, and how can you be confident that if you do break it, it would, you know, at a certain point, you're not going to affect the functionality. So our example monolith today is sort of part of an internet banking application. And you could think of something that was previously running on WebLogic or WebSphere and has a lot of technical debt, lots of classes, and lots of injecting into other classes. There were no real interfaces designed, and it's really representative of the many monoliths we're trying to modernize or re-platform to cloud today. So let me just show you the app for a second. So I've got it running here. I'll refresh that in a VM in the cloud, and I can sort of enter my name, email and mobile phone number, and I'll sort of go into a queue. Visually, I've sort of just displayed the queue for this purpose. But this is running on on my JBoss here. So I've got a JBoss server running in my VM, and I have the original, and I've got a few EARS files, and I'll sort of come on to that later. But the original one, I'm using this original bank here. So that's my monolithic sort of application. So we get a little bit more technical, and for the Java people on the call, you'll be able to sort of identify with this, but for non-Java people, I'll try and explain it a little easier. So this application, I mean, circa would have been written, you know, anywhere between 2005 to 2012. So that's sort of this typical design where we've got an EAR file, a module. It's using HTML, JSF, JSP, CSS, JavaScript as a front-end technology. And you've got sort of your model view controller design. So the model was sort of the data that you displayed. There was a view, which was sort of the HTML components I described, and a controller. And in this case, it was sort of a servlet basis. So, but then it sort of comes the part that, you know, you've also got the back end talking to the database. You've got API, sort of RESTful APIs that you need to expose, and you've got transactional sort of database classes. But when you start to inject them in code into that front end, it really starts to become monolithic. So the current build here is sort of just one single web module with a EAR sort of module wrapped, or enterprise Java file, enterprise archive resource, the official name. So I'll just show you a bit of the code because you might be interested in that. So here I've got my original web, and this is my controller class, if you like. And I've got, so it's a model sort of controller. I'm injecting, and this is where my service is just literally injected into the code. And it can be difficult to sort of wear apart. And if I jump into that member registration, now this class here is a stateless sort of enterprise Java bean, but it's also injected into sort of the database and very much tied into the data model. So there's also sort of other aspects to it. And in the real life, there is, you know, some internal reluctance to move this app to the cloud because people know it. It's like a pet. They know what it does. They know what it does if it falls over. Or if an error, they know sort of how to fix things in the database. Maybe it's a workaround. But this is sort of an important customer-facing app that needs high availability. And the rate of change in the front end is usually more frequent than the back end. But to lift and shift this whole monolith into the cloud was sort of deemed to be a really big estimate and more than it was budgeted for, and you know, high architectural changes and operational risks. Yeah. So you know, if we only have sort of maybe 25% of the budget we have that to move it, we need to find a way, you know, to sort of enhance it, to try and get part of it into the cloud with a lower risk, lower budget, and a similar time frame.
Right, and it makes sense. I mean, I think we can all identify with this. I remember in 2012 at a previous employer, we were moving apps like this into a very new Amazon. And it was exactly that. How can we pick this boulder up and move it and make it be there? But don't mess with the insides. Don't mess with, you know, because the developers need it this way. And we were ops, and so we would pick it up and move it. So this is fascinating. I'm blow it apart.
So fortunately, there is a couple of tools and a couple of you know, code analysis sort of aspects that can sort of give you a step up. And one of the first ones that I've used is simply using the plugins to the IDE, integrated development environment that I'm using. You can analyze Java code, particularly if you have to upgrade versions. You can use that Maven dependency analysis. Then you can produce a nice graph of how sort of all the components stick together. But this tool here is a migration tool that Red Hat supplies free, which runs through sort of the code and applies a series of rules and heuristics to analyze what you might need to change. And for example, from WebSphere and WebLogic to JBoss EAP, which we can then sort of run in a container, you could also look at sort of different technologies such as Spring Boot, Quarkus, or different Java versions. And it's a really useful tool to sort of get an overview of the code and an idea of its sort of complexity. So this is sort of a screenshot, if you like, of sort of the typical targets that you could select to run against. It could be, you know, let's examine the code for containerization issues. There might be a hard-coded IP address. There might be something to do with sort of a Windows file path name or something like that, and you know, other aspects. So I can select multiple of these targets and get really an output of, you know, what I might need to look at. It can also take me into the exact lines of code that would need to change. So great tool, definitely gets you started and definitely helps you prioritize, analyze the code you have. You know, within you know 5 minutes, you could sort of analyze many apps. So, and then you produce a nice report for management, and then you can then decide, you know, which areas to attack. So this actually comes under, there's been sort of a consolidation of all these sort of migration tools into what we know now as the conveyor community. And these are sort of some sample tools. These are the 6 core tools, I guess, that are there at the moment. We've got something called Pathfinder, and that's sort of a Q&A to how can I, it's more like subjective sort of view of set sort of Q&A, and it will give me how suitable is this application to be containerized. The wind up, so that's sort of the upstream of what I was talking about there. And we've got other, migration tools there, such as Move to Cube, which can generate YAML for you based on sort of a binary application that you sort of got in place already, which is maybe running on a VM. Did you have any questions, August, about that at all? Or did you want to highlight anything there?
No, this is good. Keep going.
But yeah, these are really brilliant tools, and look out for one, particularly with monoliths. There's a new one coming up actually, and it's really around understanding the bounded context of your data in your monolith. So that's sort of a new one being worked on.
And the only thing we'll add, and Dev is aware of this as well, and as you guys, we productize a lot of these and offer them as part of our services engagements and stuff. So Red Hat can assist with these movements.
Absolutely. So, thinking if you're a developer and you're working for, organization, what could you do independently just to sort of get a view of, or getting the code into shape for a start? And I usually found, a day or two spent fixing some technical debt issues before looking to optimize it is usually time well spent. And in this case, my first step in breaking this monolith was to step to decouple or break it down without actually changing my CI/CD pipeline, and just putting some structure around it. So you can see here, I've got now a web module and an EJB module, and this is still ultimately bringing in a monolithic single deployment, but the code's now structured in a better way at the back end. But that's sort of a first step into splitting it where I wanted to do. And this is around splitting the front end to the back end. And, in true microservices, you might sort of split it by domains, but in this instance, the bank's sort of changing the UI 5 times greater than it is the back end. And it sort of makes sense as a first step and to get something into the cloud, more quickly. And so then the next step was to do away with sort of that injection that I sort of looked at and enable this to be done by a remote lookup and ensure our sort of model classes were, there was some sharing there. So taking that EJB and making sort of an EJB client module. And then now without too much effort, we've found a low risk way to break it up and do it in a way we can still work with the current setup. And in the EAP version I'm running here, I can actually sort of deploy all of these three different ways of building. It's still, I've got my original module here. I've got the refactored one, which is that one there. And I've got a front end and back end, which actually are talking to each other over localhost. So let me just try and find the code which does that. So you can see here I've got my original, my modular. You can see I sort of broke it up into different modules. And with my refactored, I've now got some additional code. And so rather than this member controller having injection, it's actually using this lookup facility class here, which is sort of talking to localhost 8080, and that's on my EEP. So it can sort of run in the same version, but in the next step, you'll see that you won't have to really change that URL in order to sort of move it into the cloud. And at that point, I think, this is where we started with. It's got a monolithic web application talking to a database. It's a Postgres database in the back end. And Bryan's going to show you, how we can simply take the front end and back end and now we've got it sort of running on a containerized platform, and with JBoss, you can, we have sort of containers for that, and that we can now sort of start to easily then move it, and as Bryon will show you.
Right, so you've been this artist, and there's certainly no one size fits all for this, but it's just cool, right? I liked how you showed that, and it's still looking at localhost, and normally be like, great, now I got to change all that, but we don't, right? This with Skupper and Service Interconnect, we can do more.
Absolutely, yep. And look, Ben's done. Maybe if you could share my screen now, please, August. But yeah, Ben's actually done all of the hard work, and the rest of it. The cloud migration, everyone thinks cloud migration is the hard bit. The hard bit is what Ben just did, and it's still running on premises. I'm going to show you how to take that all out to the cloud now, and we're going to do that, and I'm going to try and do that in the next 15, 20 minutes, and you're going to see how quickly I've moved that out to cloud, right, because of the capabilities that Service Interconnect gives you, right? So as we just saw, right, Ben started with the monolith, right? And he broke that up into the front end and the back end, and they've been containerized in there, right? And so what actually happens there is, when he containerized that, is we've got his ear file that he generated here, which he has, oops, there it is there. We've copied the ear file, and we've just basically, as the integrator, because remember, I'm wearing the hat of the integrator now, I've taken his ear, I've written the Docker file for the front end, and I've got a separate Docker file for the back end. And now these things are both running as a container on the same virtual machine, right? And in this case here, I'll just quickly show you the application running, right? So it's running, this is the database there, and I've got the back end, and I've got the front end running as two containers on my virtual machine, right? And we can now use the application, right? And I'll just quickly myself in there, and we'll go, let's go, and we'll view the queue, and that's all running. So that's my application containerized. So the integrator there, I've containerized it, and everything's running on premises, all nice and sweet, right? I'm going to show you now, just briefly, going to start with the end about where we're going to end up in about the next 15 minutes, right? And as I said, we've started with this thing on the right-hand side here. We've got these things containerized, talking to my database. By the time we're finished, we're going to have the database still running on the core system. I'm going to have the back end running on an on-premises OpenShift cluster. And I'm going to have the front end running on a public cloud-hosted OpenShift cluster. Doesn't have to be OpenShift, could be EKS, GKE, AKS, doesn't really matter, right? Whatever flavor it may be, but that's where we're going to end up, right? But the first step I'm going to show you is I'm going to redeploy that front end onto OpenShift on premises, right? And we're going to do that with no application changes from this point forward, okay? But what's interesting about this is when the front end's now going to talk to the back end, traditionally you'd be doing that when you're crossing systems here. You're going to do that with DNS, right? But we're not going to we're going to talk like it's localhost. The front end thinks it's talking to the back end via localhost. So, oh my God, no DNS. How are we going to do that? We're going to do that by deploying a gateway router to the virtual machine. And then we're going to put a router onto OpenShift. And once we do that, a local proxy for the back end is going to appear on OpenShift. So the front end still thinks it's talking localhost here, but it's actually going to get redirected over here and then talking down to the data there, right? And then when we've finished that, we can now decommission the front end. Right? So now you're getting the idea about how, Ben's done that small change, refactored that as part of BAU or project investment, but now we can continue to move that thing out to the public cloud. So without further ado, let's get going. So we've got there. So let's first of all deploy the front end out to my on-premises OpenShift cluster. Just make sure that that's all deployed. It is, it's all running, good. Okay, now the first thing, if you remember, it said, well, we've got to deploy this router, right? So we're going to now deploy the Service Interconnect router to the cluster. So we're going to do that. We're going to have the site name is going to be on-prem. I'm going to enable a console that you'll see shortly, okay, in there. And so we're doing that with the Skupper init command, okay? And we can ignore these warnings. This is just about a new the next generation of Kubernetes has some extra security stuff that that you need to pay attention to, but it's Humsey's, right? So I've now deployed that out to the cluster. So let's just quickly make sure that's powered up. Yep, everything's running. Good. All right. So now we can actually see, if I come over to here onto my OpenShift cluster, I've now got my front end that I deployed before, okay? And I've now deployed my service interconnect router out to there, and I can open up the console and I can see my network. And at the moment, it only knows about itself, and that's because we haven't created the gateway yet. So let's go and do that. All right. So what we wanted to do, right, is, if you remember, is we wanted to we've got to create the gateway on premises so we can get to the back end. Okay, so let's go and do that. So what I'm now doing is I'm exposing what's running on localhost, right? Because remember, the database is running on OpenHost, port 8080 as the back end, and I'm going to Kubernetes uses service names for things to be able to intercommunicate across pods, right? So we're going to expose that as the service back end, right? So now let's actually have a look at what's going on here. So I've created the gateway, right? And now what you'll see is running the pods running on the cluster is front end, okay? And I've got a corresponding service front end running on the cluster. But what's interesting here is that there is a back end service, but look, there is no back end pod running on there. That's just how it's creating this service proxy for you to sit over there. That means that the front end can now talk to a local back end service, okay? So when we do that, let's go down and have a look. In fact, I'll just quickly show you the gateway. It's been deployed, and it's deployed back end. Port 8080 is what it's published on Kubernetes, but from a TCP perspective, this is what's happening on the local gateway, right? And from the Skupper network perspective, right here, we can see that I have a local site on premises, and it's now got a service that's made available as back end. Alrighty. Okay, so now if I go over to here, we can see on the console is I've now got my gateway available. Okay, and I'll come back to the components in a second, but let's go and try and check that everything's working. So we run that, and now I'm running the front end from OpenShift, and I can view the queue. And you can see the booking registration that I created before is there. So let's create a new one for Harry. Okay, and we can see that everything's working there, right? So that's what's happened. Now the only thing now left to do, right, is we've moved the front end out to the on-premises OpenShift. So what I can really do now is I can kill my front end. But before I do that, I want to show you how the magic's happening, right? So if I show you the service definition, right, so Kubernetes the front end is talking to the back end on Kubernetes via the back end service. And the magic that's happening here is that the way a service works is that the selector tells it what pod to redirect that service call to. Well, in this case here, the selector is actually the router. And that's what's happening. So the router is able to intercept the call to the back end, right? And then it picks it up and then says, where does that live on my service interconnect network? I find that via the gateway, and it delivers it over there. Okay, so that's the magic that's happening there. So the next thing to do, of course, is, well, I can now kill my front end. So if I look at my current pods that are running, right, we've got the database, the back end, the front end, my gateway that I created before. Well, now we can actually kill the front end because we don't need it anymore.
Right, okay? So that's removing the on-premise front end.
Exactly. So I've now the traditional front end. So I've progressively migrated that front end out to the OpenShift cluster, right? So that's really cool. So that's where we're at the moment. So where I'm at now is we're effectively at this state, right? So we've moved the front end out to here, and we've decommissioned everything. Okay. So this is where we are now, right? The next step will be to take that front end out to the public cloud. And I'm going to do that again with no application code changes, right? And we're going to do that because we're going to add a router out here, and it's going to create the back end and make it visible over there. And then we can decommission the front end from on-premises. So we'll have progressively migrated the front end all the way out to the public cloud. Okay. So with that, the first thing I'm going to do is I'm going to deploy the front end to Sydney. Now, I should have mentioned this before, is this here is my on-premises cluster, and this is my Sydney cluster. Okay. Now I'm going to terminate. It can be a little bit problematic for me hitting the hotspot there, but let's move that over here. So first of all, we'll deploy the front end. By the way, if this font size is too small, just put it in the chat and we'll get that increased. So I've deployed the front end. And now the next thing to do, but of course, it's not going to be able to talk to anything, so I'm not even going to test that there, but we know it's deployed to Sydney. But what I need to now do is deploy service interconnect out to Sydney. So I'm adding that other router, okay? But of course, if I look at the service interconnect console, it's not been added yet. So even though you can't see it, right? Even though I've deployed it to Sydney, because this console is being served out of on-premises, you can't see it on there. That's because I have to create the mesh network, right? And this is really key here. What we're going to do is we're going to set up an MTLS connection, right, from Sydney to on-premises. And the way we do that is we do it from high trust. The connection has to be from high trust to low trust. This is how I said, remember, it rides on top of endorsed network flows. So what I'm going to do is I'm going to create a token in Sydney, import it into Melbourne, into the on-premises, right, and have that then reach out and establish that connection. So let's go and do that. Okay, so I've just check everything's deployed. Let's see, get service. Everything's running, so that's good. Okay, and you can see I've deployed my front end pod that's running there, but there's no back end service there. So the first thing I'm going to do is create a token in Sydney. And the token has, all of the TLS certificate information here, and it's also got the public route in here that on-premises will be used to find that other cluster. Okay, so the next thing we're going to do is, if I can just move that down there, I can move that down a little bit. We're now going to import that token into the on-premises cluster to establish that connectivity. Okay. We're going to create that link, and we'll just give it a moment because it takes a little while for everything to stabilize, but let's have a look at the network status. Okay, and now you can see is I've got on-premises router and I've got a Sydney router. The back-end service is available on-premises, and it's also automatically available over in Sydney. So now if I go get my pods and service in Sydney, you'll see I've got the pod running in front end, but the back end, and it's down here, but the back end service is now immediately visible. What does that look like from the console? And so when the router refreshes, sometimes the console needs a bit of a kick. So we'll just relaunch that. I've now got 3 sites, right? As part of that, I've now got Sydney connected from on-premises to Sydney and then back into the gateway. My components I've got running. I've got whatever's behind the gateway and my front end, and a component represents a collection of pods that have the same name, right? Are part of the same deployment, irrespective of where they are. And the processes, right, that are running out here, well, there's a link from the front end to the gateway here from on-premises to there. There's been no traffic yet, so you'll see that there's nothing going there. So let's actually go and run that, right? I now launch the front end from Sydney, and I can view the queue, and hey presto, I've now moved that front end out to Sydney. It's integrating all the way to the back end that's on premises. I didn't touch a single line of code, right? And I did it in how much time? Probably about 5 minutes or up. If I hadn't been talking, I could have done it in 35 seconds.
Right, and it's all because it's all just talking local. Well, it thinks it is.
Everything thinks it's talking localhost, right? And all I'm doing is I'm just creating this, using the mesh to actually just publish the proxies there, right? So now I've actually got that thing running in Sydney. I can now come back to on-premises, and now I can actually delete my on-premises front end.
Scary moment, right?
Yeah. Yeah, 1 second. I think I've got it at -F. Right, and now that's deleted there, right? So now I've deleted that front end that's on there, and everything's still running in Sydney, obviously, right? Okay, so that's all going there. That's really exciting, right? So now what we've done is we've ended up with, we've moved the front end out to there. We've decommissioned the front end. Should be there. We've gone here, right? And we've decommissioned that front end. The next step is we're going to move from here, right? And I'm now going to take the back end and I'm going to move that to on-premises and decommission the back end on there. And then we're going to end up with this situation where the front end is going to be running in the public cloud, the back end will be running on premises, and then the database will still be running on the traditional infrastructure. Okay, so let's go over to that.
So this traffic will be TCP-based traffic, right, Bryon, rather than...
Yes, so now that's right. The connection to the database will be via TCP-based traffic. That's absolutely correct. So the first thing we're going to do is we're going to expose the... if I look at on-premises, you see I've only got the back-end service that's been exposed. The first thing we're going to do now is we're going to expose the database, right? And now that's going to make that available to Kubernetes, right? We're using the service name DB, okay? And if I now look at the services that are running, I've now got a DB service available to OpenShift. Right? There is actually nothing running on premises at all apart from Service Interconnect, okay, that we've got there. So that's kind of interesting. So now what I'm now going to do is I'm going to deploy the back end to on-premises. Okay, that's creating there, but run. There we go, that's all running. Okay, so now what we can see is I've deployed the back end on premises, I've got the back end service available there, and I've also got the database service there. Now, if you remember, all right, gateway, oops, typo, it's two things now. It's got the back end and it's got the database, but I don't need that database anymore, that back end, because I've got the database back ends deployed there. So what I'm going to do is I'm now going to unexpose that back end. Okay, so we do that in there. That's good. And then what I can now do, actually, I just want to check. Sometimes when you start the back end, it there's trouble connecting. So OC logs. Just want to check that it started up okay. Yes, it did. Right. We go back to here. So as you see now, the only thing running on the gateway now is the database. Okay. Right, and the database is available on premises, and but what I haven't done yet is made the back end available, right? So what I now need to do is tell, if you remember back when I very first started this, I exposed the front end to the Service Interconnect network, right? So if I go here, OC get service in Sydney, right? All I've got is the front end and the database. I now need to take the back end that's running on OpenShift and publish that to the Service Interconnect network. So I'm going to expose that deployment back end and you communicate it via port 8080. And once that's done, if I look in Sydney, you'll see the back end is now available. That means the front end in Sydney will be able to talk to the local back end, and then the back, which will hit the back end that's running in Melbourne. Okay. And then we go. So if we can now actually quickly run down here, if I come over to the routes over here, I'll launch the front end in Sydney, and I view the queue. I can see everybody's booking that's been made in there. Let's book one, make a booking for Fred.
Good old Fred Blogs.
Fred Blogs. Right. In there, right? And so now what's actually happening here is, so, oh, okay, that was a bit interesting. Let me just find the other node so I can drag it over. rendered a little. This is a brand new version of the console, right? So it's kind of exciting what's happening here, and you'll see some flows that take a little bit.
But this is beautiful, right? I mean, being able to visualize, you know, I'm watching you and I'm thinking, oh, what's happening? I want to take notes, and this is wonderful to be able to see it like that.
Yep. So we've got Sydney, right? The front end is talking to the back end that's running on premises there, which is talking to the database over here. This front end here, which was still running on premises, the cache will refresh in probably about 5 more minutes, and then that one will disappear. So that's lingering around, even though that doesn't exist anymore. So the only thing I now need to do, right, out of all of this is, if you remember, we've got the back end still running in as a container on premises. Well, I can actually now the back end, that's not needed. But now all I've got is my database on premises, my gateway that's running there, and then my back end is running on premises, right? And then my front end is running in Sydney. And so now I've decommissioned everything, moved everything there. And what we're actually now got sitting there is we are now here. So we started with this monolith that Ben broke up, showed you how you break up a Java monolith into different EAR files. The integrator could then take those EAR files, put them into Docker containers that can then be deployed and run on a virtual machine. The integrator then was able to take those and then progressively migrate them out. So now you've got your database running on premises. We've put the back end onto the OpenShift cluster on premises, and then the front end is running out in the public cloud. What's really an important takeaway here, right, is that when we did this, is the unit of change was tiny. As that implementing that business feature, we've now containerized that, and I can take that stuff all out. I don't need a big migration program. This is the next generation of cloud migration is what I'm talking about, right? This progressive migration, right? So we strangled it, as I said, into the virtual machine. We packaged it into containers. We prepared the application for cloud using OpenShift. So OpenShift is that stepping stone to publish cloud. And then we demonstrated that locationless application and progressively migrated all of those out to the public cloud. Okay. And that's, as I said, it can be done with normal application lifecycle planning. And that's kind of the end of the story, right? All of the hard work was done by Ben.
Which makes you the smartest guy in the room. So it's funny because as we were prepping the show, we talked about naming, and it was the evolution of cloud migration, or is it the next? And I get the next now. This is not the end. This is, we're into a new phase, right? This is, you know, and Bryon has shared this internally, of course, a lot, and, you know, wherever you can find him, he'll talk about it. But wow, when you see it like that, I mean, Dev, how far have we come from standing in that telco exchange going, we're going to take that old piece of equipment and make a VM?
Absolutely. I was just thinking of the same thing, August. Initially, we were kind of debating, you know, the title of this whole presentation, and I was, you know, we had our reservations. I was thinking, is Bryon and Ben going to bring in a new R? You know, is there another 7th or 8th R? Because, you know, like, bringing it from monolithic to microservices, it's hard, right? The whole migration piece is hard. It involves a lot of effort, a lot of time, and cost. And, you know, think of it from an application owner point of view, right? They really want service continuity. They want, you know, the best out of, you know, whatever resources they've got. And, you know, the way Ben and Bryon showed us really seamlessly, you know, move from, you know, monolith to microservices, how it can be extended. It is location agnostic, right? It's I think in its true sense, when, you know, Bryon initially mentioned simplified hybrid cloud, you know, architecture, it really brings it back. And to be able to visualize all these flows, it really becomes simple, you know, because from a developer point of view, it is zero code change. You know, if I think about it from an integrator point of view, it's really, you know, simplified and agnostic, and brings it home, you know, if you were to say. I have one question for, you know, you both, and really thank you for your whole demo. I really loved it. I enjoyed it. I'm excited to learn, you know, I'm sure you are championing it with all our customers. I'm excited to learn, what you see, that customers are asking in terms of use cases, and what has been that question from the customers.
Sure. Do you want to take that, Ben, or do you want me to take it?
You take it, Bryon.
Sure. So the use cases, I mean, we've shown you one use case for this, right, which was about progressive migration. But there are other things you can use it for. So from a multi-cloud, so there's this idea that if you're on premises, you can create from an application point of view, even though you're running on multiple clusters, a single cluster experience, right? Which is really, it takes a lot of using a global load balancer to deal with, and then having to do with sticky sessions and things like that becomes really, really hard, right? So you can actually create this single cluster experience for your application, which simplifies your application architecture. The other thing you can use it for is cloud bursting, right? It actually works really well for cloud bursting because the router is a cost-based router. So if you're actually calling something that's on premises and it's becoming non-responsive, it's overloaded or whatever, it can legitimately just burst out the cloud as it needs to be. So you can actually do real-life cloud bursting. It's not actually all academic. Disaster recovery. Right, you can actually use it for that because my application can be, being locationless, it can be anywhere, right? Or if you have to deal with, if you're a regulated entity and you've got to deal with a multi-cloud scenario here, right? I can actually have my applications active across clouds or fail over across clouds really, really quickly. And it does this, the application team's in charge of it, right? Not a platform team. And so there's only like 3 moving parts with Service Interconnect. The other thing is, if you've got some like third-party products like Redis, RabbitMQ, Kafka, that none of them work in a multi-cluster scenario, right? What you can do is you can actually make those things work, think that they're working on a single cluster using Service Interconnect. And normally the way you'd have to do that is opening up node ports, right? You'd need a global wide area network and either using Submariner or Istio multi-cluster, right? Which are all very, very complex solutions. This I can actually have a globally distributed Redis cache, for example, right? And all running on Kubernetes, and it doesn't know because Redis thinks it's working all in one cluster. It's being tricked by Service Interconnect. So it's about third-party products that need to run only run on one cluster, but you can make them run across multiple clusters, right? And all of those other use cases that I talked about.
Yeah. It's amazing because sorry, Ben, go on. Yeah.
Oh yeah, I just love it because it's fast and easy to set up. You can see how, within a few seconds, Bryon had connected those sites. He had connected the services, even for developer use cases. It's fantastic. Like just to be able to say, I need to connect to the database to test my little solution on my laptop. I could do that with Skupper. So there is lots of benefits to it.
And it can just be across verticals. I mean, I was, wanting to ask, where are you seeing it used? But I mean, come on, where won't you see it used?
It's really a Swiss Army knife. It's amazing. Every time there's new use cases that pop up for it all the time, right? All I'll say is it comes with one key requirement: is it needs a stable connection between the routers. It can't be one that's floppy, right? Because the routers need to establish where you can, so you want to, if you're using an edge, it needs to be a connected edge. Right, things like that. So that's the only thing I'd say that you really need, and then the world's your oyster with it, right?
Wow, very, very impressed by this, and I'm really excited. We had been planning and talking about the show for ages, and to have the demo, and I'll say it now, the demo worked. There was any issues there. Everyone always says before demo, pray to the demo gods. I purposely did not say it. Everyone was just like, yep, it'll be fine. And it worked really well. So, I mean, look, this is cool. If they want to reach out to you all for more information, I'm sure that's okay.
Sure thing. Absolutely. Yeah. Yep. I presume my contact details are in the somewhere in the chat for the YouTube, or you'll put it in the chat.
We'll put it in the show description, your home phone number, the whole bit. And then of course we talked about this before, but it's being talked about more at Red Hat Summit. And if you happen to be in Boston in May, head on over to and sign up. Or if you're interested, please reach out to anyone on the show. We can help connect you with resources over there to learn more about this and talk more about it. And because wow, yeah, we are definitely into a new space here. You convinced me.
Yep, absolutely. And look, thanks August and Dev for having us along. Really appreciate the opportunity, and everybody, yeah, you heard it here first, right? This is a pre-summit announcement we've gone through Service Interconnect.
It's brilliant. All right, well, another awesome show. Again, you can follow us along at the live streaming calendar. We have another show coming up soon. I think in about 2 weeks, we're going to talk a bit about security, so that should get very, very interesting and fun. But for now, that's about it from all of us. So guys, Bryon, Ben, any last words or anything else you want to add?
No, everything is good. So have a great rest of your day, wherever you are, and thanks very much for taking the time.
Awesome. Cheers, everyone. Enjoy your Kopi. See you next time on the Kopi Hour, and I'll take care. Bye.
See ya.